This video will demonstrate how to use the algebraic method to balance the following chemical reaction. The first step is to assign dummy coefficients. So A, B, C, D, and E. The next step is to use what we know of the individual molecules as well as the dummy coefficients to write out equations for each element. So we'll have one for iron. However many of these we have is governed by the coefficient A. And each one will have 2 iron atoms, so that's 2A. No irons here, but we have an iron here, so 2A equals C. In the same way, we can create equations for oxygen. 3A equals C plus E. Nitrogen, where we have that B equals 2D. And hydrogen, where we find that 3B equals 2E. So far, I've made no decisions about doing anything, and that leads us to step 3, which is the thinking step. We have to look at what we have from the equations and determine if I let one of the values be equal to something specific, that I can determine everything else. If I choose a value for A, that gives me a value of C. Knowing the values of A and C will allow me to determine a value for E. If I know a value for E, I can determine a value for B. If I have a value for B, I can determine a value for D. So, to begin with, let's let A equal 1. If A is equal to 1, then 2 times 1 equals C. So C equals 2. If I have A equals 1 and C equals 2, that means that 3 equals 2 plus E. That means that E must also equal 1. I now have a value for E, so 2 times 1 is 2. 3B equals 2, which means that B must be 2 over 3. And B is equal to 2D, so 2 over 3 equals 2D means that D is going to be equal to 1 over 3. Now, the next thing I have to do requires a little bit of thinking, is recognize that I have fractions instead of all whole numbers. Since we prefer to balance reactions using integers, I'm going to take all of this and figure out what I can multiply by to get rid of my fractions. I can multiply everything by 3, and the new values then are A equals 3, B equals 2, C equals 6, D equals 1, and E equals 3. It's left as an exercise to substitute these values back in for the individual dummy coefficients and verify that we've achieved balance in the number of iron atoms, oxygen atoms, nitrogen atoms, and hydrogen atoms in the chemical reaction.